as the attendees. So I thank you all for joining in today's webinar. Uh, Before we begin, I would like to take a moment to introduce ourselves. Like I said, my name is Ahmed Uzair, and I am part of FAANA, which is FAST Alumni Association of North America. FAANA was formed to reach, serve, and engage the FAST NU alumni residing in North America and help connect the university and its graduates. Um, FAANA's mission is to support FAST NU through alumni and provide a platform to counsel and support graduates for the last several years, we have been supporting deserving students via financial aid program. And going forward, we are expecting to invest more in the areas of research and development and promoting innovations across various FAST campuses. Uh, Today's session is going to be about data science practical applications in retail industry, and it is going to be given by Mr. Hamza Farooq, who is a graduate of FAST Karachi campus of 2004 batch. He graduated in 2008. And he currently is based out of Sunnyvale, California, working for Walmart, which is the industry leader in US and all around the world. He currently leads multiple data science teams. And Working on machine learning and optimization products to provide recommendation in the assortment, replenishment, and space domain at Walmart stores. He has over a decade of experience in data science field and have helped build multiple machine learning algorithms to solve real world problems, deliver meaningful results, and accomplish critical business objectives. Uh, so this is the introduction of our guest speaker who will be taking over the presentation shortly. Uh, and I think we have 6 attendees right now. I just want to make sure that we have enough attendance before we begin. So with this, I welcome you all to the third session from the recently launched webinar series under the banner of FAST Alumni Association of North America. Like I said, the upcoming session is going to cover data science practical applications in retail industry. The main target and the main goal behind this conducting this webinar series is to engage more and more alumni onto the same platform and to create awareness about various up and coming fields, tech fields, and to provide a uniform panel or a uniform platform for the alumni to come together and discuss various ideas. With that being said, I would like to hand it over to Mr. Hamza Farooq, who is going to be our speaker for today. Hamza, over to you.
Hey, assalamu alaikum everyone. Zair, thank you so much for the opportunity. First off, I want to make sure that everybody can hear us. I know we have 7 people joining in. You guys can just reply with a yes in the chat so that you can hear me. Let's start with that. And then one more thing is that, can you all see my screen and what you can see on my screen right now? Uzak, what can you see on my screen right now?
So a day in the life of a data scientist.
Okay, perfect. So what I wanted to do is that since
Hold on a second. So the feedback from the participants is I could hear you but see a blank screen.
yeah,
Uh,
yeah, I'm
so yeah,
so this should be fine now,
yeah,
right?
yeah.
You guys can all see this,
Right. I can see the Walmart Labs a day in the life of a data scientist.
right? Perfect. So I don't know how much. I mean, was there? Let me know about the timing.
Yeah.
How?
So roughly we have like 1 hour.
Yeah, and then I'll actually what I'll do is that I'll go through the deck, and then I want to open the floor to questions because this is
Sure.
more, hey, what do we do? How do we do?
Sure.
So let's start with that. This is an old presentation that I made. I usually give this as a starter presentation, and because there's varying levels of understanding of data science in the system, these are some of the projects. So let me start with some of the works that we do. There are four major parts of our process or any data scientist that you work with. There's data augmentation, there's algorithm design, there's scalability, and there's deployment. Uh, this is in a way a full stack engineer, a data engineer, and a research scientist put together. The first part is the data augmentation part, which seems very basic, but this is I don't know if Naman is there on the call, but he would agree that creating data and cleaning data and being able to understand data takes 80 to 90% of your time. So data augmentation is one of the biggest and the most important part where, and it's not just one data, it's like we literally pull data from 25, 30 different tables and they have very, very complex joins. And the data that I'm talking about is about, let's say we use about 100 terabytes of data. All the work that we do is on the Google Cloud. We use GCP for all our work process, and all the pipeline that we create is built through a tool called the BigQuery. And most of the things that we run our work on is on R or Python, the notebooks. All right. So the first part is data augmentation. We created ETL layer, backend data. Then the second part is that we do the algorithm design. The challenge with algorithm designs with Walmart is that it is very difficult to actually use any current algorithm that is existent in the system, because all of those things are based on certain assumptions that the data is good or the data is created in a certain way. The problem with Walmart is that the data created at our end can be extremely sparse and extremely rich at the same time. So what we do is, I'll give you guys a very simple example. We have 5,000 stores in US only. 5,000 each store has about 250,000 items. Now, each of those 250,000 items is bought by 100 million customers over the year. We have 365 days in a year, and we use almost 3 to 4 years of data to build our model. So you can imagine that the number of zeros start adding up very, very quickly. Right, so that's the algorithm design part, where we try to understand that how can we learn from current principle algorithms and make an algorithm that basically makes our work into a smarter way. Scalability is scalability is turning all that data and algorithm in a way that it can be used throughout all the stores, throughout all the merchants, and how can we learn from it. So scalability is also a very important part. Again, we use Hadoop clusters within GCP or wherever they're deployed. And then the deployment is basically a product management work where we deploy the solution, and anybody who's within the system has access should be able to use it and run through it. Uzair, I want to pause and I want to open if anybody has any questions for me at this moment.
Yeah, sure. If anyone has any questions, please feel free to uh, type in the chat box, and we can take those questions as we go along.
Right. Okay. And I usually like a two-way conversation, but this is fine at this moment. Right. So understand the reason I really like this slide, and I always show this slide to everyone, is that this is the foremost and the backbone of any data science work that anybody does anywhere in the world. All of these four components, they can be divided further into many different small parts, but this is the most important part that I like to talk about, and it really shows the capability of what you want to be. If you are a data engineer, you can work on the data augmentation. If you are a full stack engineer, you can work on the deployment side, you can work on the scalability side. And if you want to learn about math, if you want to learn about modeling, if you want to understand how those things work, you can work on the algorithm design side of it. And then when you put all of them together, you become a true now. And I'm going to go talk about a few use cases that I've implemented in the past. One of the questions that came up was about deep learning, that how do we implement deep learning, or what are the use cases of deep learning? Well, this is one of them. Now, whenever we are in any store, be it Nahi, be it, I don't know which one's in Pakistan now, but Metro, I think there's one of them. So what happens over in there is that, whenever you are in a checkout counter, you see items, you see chewing gums, you see chocolates, you see things in the shelves over there, right? And what happens is that when you see those shelves, it's called impulse buying pattern. You basically buy something on an impulse, and you wanna pick it. We estimate that just because of being out of stock, we have about Walmart registers that they have lost sales about $65 million just because you are out of stock. Basically, it means that someone was not able to stock the items in time. The shelves were empty. So if you see, there's an empty here, there's an empty here, there's an empty here, and there's an empty box over here. So all these boxes are empty. What this means is that there's a potential customer who could have bought this item, and they were not able to. They did not have it there. So what we did is that we used deep learning model, which is basically I can get into the depths of it, but in a way what we did is that we created a very simple mechanism of image recognition of what looks full and what looks so what I did is that some of the questions in IoT would also be answered over here. So we took a Raspberry Pi camera, and we implemented on top of some of the shelves. And what we did is that we would take pictures, and we would parse this image into different blocks, using different markers and different things. That's another conversation. But we basically we basically created those grids, and from those grids we could tell is that empty, it would generate a red. It would red means empty, yellow means it's almost, it's halfway, and green means it's full. Now this is a very simple, and we actually implemented 2 patents on it. We got it patented, this algorithm and approach. But imagine this, that you are very simple computer vision. You pick up a methodology, and this is a very easy use case to implement within stores. This became such a big project that Walmart actually went ahead and created a new company called IRL. And IRL is a company that literally only works on identifying how a stock up happens. So let me go quickly online and see if I can share this link with you guys. One second, guys. I know my screen went blank. I'll come back to you guys on that. So so what I'll do for you guys is that I'm gonna go ahead and share my screen again, new share, and you guys can see the desktop. Can you guys see my screen now again?
Yes.
Right. Okay, so I'm gonna move this here, and the game is still on. Okay, so I'm gonna open this website. Okay, this is our website called IRL. And what we did is that we worked with them, and then so imagine you see this woman coming in, and then as soon as she picks up, it says that the item is out of stock, and it says the item is out of stock, and a associate or a person at uh, the the shop, whoever works at the store, was basically able to identify this item is out of stock, right? And imagine if you know how often your items go out of stock, you can actually detect that, or you can actually make a pipeline. Is that what is the process of how often a customer item goes out of stock, how often these things happen, and how often you need to put them together. So um so the reason to show you guys this was to tell you guys that a very simple concept can be taken further and could be made into something really really amazing. And this is what my team worked on in the very beginning, and now it's a separate company that Walmart incubated. It's called Storate. It's under the umbrella of something called Storate, and then the company is called IRL. You guys should take a look. I was with them last week. So very good implementation of deep learning and computer vision. All right, now this is actually very directed towards customer behavior. Uh, let's say let's say you have customers walking in, and they have a thought process of how they want to buy or how they want to shop in a category, right? um, so what happens is, hello, I'm sorry, I think I lost you guys for a minute. Can you guys hear me?
Yes, yes.
Sorry, I think I don't know, I think it got muted or something. Let me go back. Okay, so let's say you want to divide a category into something. This is very specific to retail, but what this example is trying to help you is that we look at customer shopping pattern over the years, then over time, and what we are able to do is that we are able to create a hierarchy of how a category is divided. Now, let's say you go and you want to purchase a headphone. Within headphone, we've identified there's wired sound, there's tone wireless, and then wireless music enthusiast. And then within that, there are multiple divisions, and as you go to the right, you'll see that the groups become smaller and smaller. Now, one of you would say that, oh, you can always do that by reading the attributes of a category, like why you can just make it yourself. The problem is that we have about 600 different categories, and in 600 categories, what happens is that when you're working with those 600, and you can't manually do every single thing. You have to sometimes do things using machines. So what we did is that we took a customer shopping pattern in terms of attributes of what they were shopping and what they were shopping together. And from that, what we were able to do is that we were sort of made in groups. So let's say this is for headphone. This is for food storage. So basically, these are small boxes that you have at home. The reason we use them, or the reason we implemented them, is that, for example, you have two kinds of stores. We have Walmart has something called a neighborhood store and something called a super center. A neighborhood store is something which is smaller in size, so that you can only get the essentials. And then there is super center, which is very big, and they have all sorts of items. Uh, the reason to identify this was that if you had, let's say you have a shelf which is 8 feet in neighborhood market, and let's say you have a 24 feet shelf in super center, what item from each category would you need to keep in order to satisfy the customer who walks in a smaller store versus the customer who walks in a bigger store, in a 24 feet store? So the difference comes from that what we did is that we identified these groups and we picked up at least 2 or 3 items from every group. This is sort of way trying to differentiate within a category how many different attributes or how many different style of things are out there. So we can have, so what we did is that we picked up everything on the right hand side. So basically at level 4 and level 5 we picked up toddlers to preteen, all ages. I don't remember what MQ Bix is, fashion earbuds. We picked up everything from there, and we put at least one item for neighborhood market. And as we go, or as we move on to bigger store sizes, we're able to bring in more quantity. So the fact is quantity versus diversity. So these examples identify the diversity, and then the quantity comes from the size of the mod. And the way we used, so this is basically the core of, and I understand most of you have not worked in retail, so you won't understand this, but this is literally the core of merchandising, is that given a certain shelf space, what items should you keep which will increase your sales the most, right? And this is the challenge that we have had over here, is that it is very difficult to identify the items to keep versus a customer need. So the core of retail has always been to identify what a customer, who is the customer, what are they shopping, what items should we keep in order to increase the exposure, and overall, lastly, is that how do we improve their overall experience. Again, folks who have worked in retail or who have an idea about retail, this slide is the core of any retailer, of how would they use to select the items that they want to keep. And then the third use case is the fact that, let's say we have, let me pause here for a moment. I think I'm getting messages on the chat. So Tahir is saying this looks more like a dendrogram and less like what we call a decision tree in ML. So Tahir, this is a kind of a dendrogram. This is essentially the algorithm that we use for making a dendrogram. But what we do is that we sort of use attributes to identify. We use attributes to identify the nodes. So we divide it into a decision tree because we say a person wants to buy headphones. The next level of decision is that what kind of headphones do they want to buy? And then from there we go on to see that, what are the different varying attributes. This is, for example, you want to go buy yogurt. You go to a yogurt aisle, and then from yogurt aisle you first say, okay, do I want low fat or full fat, or do you want a smaller size or a big size, or you want to go with a brand. So there are multiple varying ways, interest or ideas of how you can make a attribute decision tree. Like I said, there are two major things which are used over here. There's a data augmentation. So we use the attribute data to understand customer behavior over time. That's number one. And number two is that we use the algorithm. We fashion the algorithm in a certain way so that it picks up the attributes instead of making segmenting the items in a different way. However, this is actually built from a graph. We actually use graphs, the clustering algorithm from graphs, to actually put them together. I can there's a lot of work that I can discuss with you guys on how we created or how we fashioned the data. But essentially, if you were to look in a naive way, you would say, oh, this is literally a dendrogram. Again, a dendrogram is nothing but things which are like each other put together and clustered together until a certain error is reduced. We fashion the data, we change the data so that it matches that algorithm. The third use case is it's one of my personal favorites, is that what if you were to remove an item on the shelf? Let's say these are 5 tasks, are, we call them substitutes of each other. You have a space on a shelf and you can put only 5 items instead of 6. Which one of them will you remove, and what will happen to the transfer of demand and or let's say you remove A, the question then comes that would all the sales transfer to B, C, D, E, or you will actually lose a customer who used to shop A only, or who is very interested in buying A only, and he would not, and he would not be interested, or he would walk away. So we design experiments to actually test these things out, and demand transference is something that is a very is the holy grail of retail, because what all merchants are interested in is that I have limited space. Which are the best items that I should keep? This is a very similar problem to Google PageRank, is that you probably don't want to go to the third page of your output, even though you go to the third. Sometimes you are very desperate, you go to the third page of your search result. However, what mostly happens is that you try to find your answer in the first two pages. So in terms of page rank, consider this to be page rank, is that if you're on the second or third page, the item gets removed from the shelf. The our .com or e-commerce website has a similar problem, but for them it's like, which is the best item to be displayed in the top 5 ranks on the search. Okay, so I'm going to stop here again, and if anybody has any questions in the chat, they can push it my way and I can answer them. Okay. And I don't think this is important for you guys, but this is basically the structure that I have, is that you don't see Python over here. I don't know why you missed it out, but basically,
I think Tahir has sent out another question. So
okay, let me see. Okay, this looks more like how do you sample within a category a certain level of the tree using discriminatory. Okay, so Tahir has written, this looks like a okay, no. How do you sample within a category at a certain level of the tree? We don't sample, we use all. Okay, never mind. You're using discriminated features, attributes, marginal reward, or utility, and it refers to, see, so basically what we do is that we use RL. We start with a hypothesis that this is what's going to work, and the way this goes on is that how we create a shelf layout. So what we do is that we've created an RL backend, and what it does is that it picks up the feedback as that, is the substitution really happening? So we learn all of that through the use of experiments. Again, RL is something very, very new for us. Sometimes there's a difference between being in the research, and there's a difference between being in the production. Production is usually sometimes a year behind or something, but we've picked up on RL, and what we do is that there are two implementations that we're doing for RL right now. There's a pricing initiative, which is more like it's a faster feedback. So what we do is that we change pricing of an item, and we see what is the feedback, and from that feedback loop we change them. We continue to change them and find out that what is the relationship change in price and customer behavior. That's one. And number two is that we use RL over here in experiments, is that we keep rearranging the shelves, and we try to see what is the customer behavior, customer feedback if you change the behavior. Again, we use for that we need about 3 months. 3 months to actually go ahead and implement that. Does that help you? Does that help answer your question, Tahir? Okay. Right. So okay, so that was all from my end to talk about the the work I do. So this is all about the work I do. Now let's talk about some of the things that I wanted to further discuss. Was that I do not have the deck open on this laptop, but we can just walk through some of the things that I'm working. About the second part of it is that I'm working with a team of data scientists, and we're trying to figure out of how we can change the way we travel, or how the way we make bookings, or how is the way that we make. Okay, so there was another question with Tahir. Do you change layouts while in production, and how much of the customer sample size is touched per experiment? So, Tahir, I'll give you the exact number. This is a very, very good question. What we do is that we have something called a relay period, which is between 3 to 6 months. So we identify the statistically significant number of stores which are needed to measure the impact. Like you don't want to change um, one store or two store and think that all 5,000 stores will change. So we basically find out that okay, about based on the statistics, based on the mean and variance of a category, we have about 140 stores that needs that change. So based on that, what we do is we pick up those stores and we identify a test and a learn. So a test and a control store. So we pick up a twin store concept. So a store which is exactly like that store, same geographical location, demand, and so on and so forth. So that there's no difference in the, if you run a t-test, there's no difference in the p-value. Or so what we do is that we take it and we make changes in one store and we keep the other one constant. And we do this for about 135, 140 stores, and we run that experiment for 3 to 6 months. Usually, we have seen in that within 3 to 6 months, we're able to catch up. We're able to catch up a turnaround in cycle. We're able to catch up the changes that come through, and we're able to adjust after that. But we don't do something overnight. Like we don't wait for things. We don't say, okay, we're going to do it for 1 week and then we're going to change it. We stretch out something for 3 to 6 months, and we've been in experiments for almost about 1.5 years. Some experiments have gone really well and some experiments have not been too well. Of course, that's how you learn, but we use those to learn further, or how to improve our algorithm, or how to understand more or learn more about how things work in the more retail sector. So much so that starting this year, all data scientists in my team, they were given a store to own the PNL, which basically means is that a data scientist has the ability to change or create a layout of a store the way they want to do it. And what that did is that your pay will be directly linked to the profit and loss of that store or that specific category that we are working with. So every store, I mean, for example, every store generates about $100 million, and one of the categories that we work with, let's say they generate about 1 million a year. So we have data scientists who are responsible for generating about $1 million out of the store. In a way, my PNL, me as a data scientist, have a PNL about $100 million. I'm responsible to look over that, because what the data scientists were saying is that we do not get to go into production, or we do not see things at the end of the day. So however, when we go further out, we see that this really works out for us.
So, Tahir, I hope this answered your question, but just so everybody knows, I've unmuted everyone. So I think if you guys have any live questions, you can ask that as well.
Yeah. Again, as you say, the PNL idea is cool. It was the data science idea, actually. The data scientist said, um, um, the the data scientist actually said that that you say that we actually wanted to go ahead and do that. So again, this is the first year that the data scientist actually stood up and said, if we do not get to make enough impact on what we want to work on. So they sat down with us and was like, are you sure you want to do that? And we said, yeah, we're going to do that. So far it's worked out. So far I have my job. However, it's a very interesting concept that we directly own. But this is true for most of the data science.
Ceilings are lower.
Uh, I hear some echo. Does anybody have a question?
I have a question. This is Ahmed Malik. Thank you for this very informational session. It was a bit advanced for my background and my knowledge. However, I mean, would like to be in my organization at the same spot where you are at, and then maybe in a next 3-4 years we could get to that level of complexity for data analysis and those activities. However, I wanted to ask, uh, our company is not a retail, but it's kind of a retail-like environment, and we have about 900 individual sites there. And it's a different business. It's a childcare business. So we have 900 schools. So we have a good data warehouse. We are focusing on uh, uh, just producing reports to make decisions and understand where are the issues and how do we resolve it. But we are not been. We are trying to jump into the data scientist area, data science area. So, what advice do you have for us as we embark in that journey? How would you advise us to get started in that?
I'll tell you this very simple. I started with the slide, my first slide, and I'll go back to the original. Sorry. The first thing that a data scientist wins over, or is the first and the foremost thing that you should look for a data scientist, or to become a data scientist, is to improve your problem solving skill set. See, the thing is that the word data science is or data science itself, or deep learning, all these things are very loosely termed, and it's a very loose term to use. Like, sometimes people think, oh, a data science is a magician who will do everything. Here. But all what a data science do is that they find pattern, and they do some sort of intelligent automation. Again, it's up for debate, intelligent automation. There's a rule-based approach, there's a prediction-based approach. Those are two separate things. But first foremost, I would ask people to improve their problem solving skill set. Is that literally, if you have nothing but Excel, can you understand pattern of data by using Excel? Can you sort of cut and slice data and make and derive insights out of it? So again, problem solving, be able to run data or create insights from even using Excel. And then there are two more things. So one is that being able to be a good data engineer. Every data scientist should be a good data engineer. If you're not a data engineer, or if you do not know how to pull data, there's no role for you to being a data scientist. And I can say this with authority. I've been working for 5 years as a data scientist. I have seen people fail. I've seen people succeed. Being able to pull data and being able to run data is very, very important. And lastly, the term comes is that, I think there's one more after that. One is the being able to understand math, writing code, creating algorithm. And last, and I think foremost, is being able to communicate. So Ahmed, I think if I were to put things together, problem solving, technical, and being able to communicate. If you can't tell a story from your data, then there's no need for you to be in the room of trying to go, anybody who's trying to say that we are a data scientist, if you cannot tell a story from what you're doing or how your data or why your data is producing the result. Does that answer the question?
Yes, so that answers very eloquently on what skill set competency a person should need to have to become a data scientist. My other part of the question is, how does an organization justify a need for data scientists? What type of problems can we say to our executives, okay, this is the type of problems we could solve with data scientist type things?
I think the difference comes when you talk about, do you want to be more intelligent or do you want to be an automation company? Again, the example then comes is that you have you can tell the computer exactly what to do, or you can generate results like you do, like you're saying you want to do reporting. However, if you want to generate any kind of insight, I'm not really familiar with the work you do, but what I've learned in retail is that, I'll give you a very simple example. Our retail, our logistics in the retail company. I don't know who's talking, but whoever it is, can you please mute? Can others please mute? There's a lot of background noise coming. Anyway, so what happens is that we have a logistic group. Walmart has a logistic group. It's one of the biggest logistic groups in the world. And the number of miles we do is to the moon and back. That is the number of miles we do every year. Now, we've been running logistics for many years. However, can we push the envelope to increase the efficiency, to make sure that we're meeting on time, to make sure that we are reducing the cost, to make sure that the drivers routes are more friendly for them? Can we create a scheduling system that can understand the different needs of a driver? I mean, for me, these are 5 different questions that data science can help you answer. Now, on the other side, you have, let's say you have a shelf layout, and everybody knows that like keeping an item at the eye level is always drives the same. Is there actual science behind it that can validate that? Is it true for one category? Is it true for 5 categories? Is it true for all 500 categories? That's where your data science will come in again to help you with that.
So Hamza, I just wanted to jump in. This is Uzair. So I think the session is going really nice, but we are kind of going towards the end of the time. So what I would like you to do is maybe take next 10 or so minutes to talk about your startup idea, and then we can come back to QA towards the last 10 minutes of the session. I have some good, interesting questions from the participants.
Sure.
Just to mention, Hamza is also working on a startup idea, and he would be quite interested in engaging some current FAST students, probably for some like 2-3 month internship. It would be a paid internship, and he's working on some very interesting data science project. So yeah, Hamza, if you want to talk more about it.
Sure. Right. Yeah, right, Uzair. So so I'm working on a startup idea which is about bringing AI, or making travel more intelligent versus what is right now. For example, when you work on when you go to Expedia and you type in a flight or a hotel, you get like 100 different options, and you have to maneuver through them to find out what's best, or what works for you. That's one thing. Second thing is that we have all these travel books and travel websites. How can you create a synthesis from 10 different books and find out what works best, or make an ensemble that this is what these 10 books are saying, and this is what we can learn from this. So this is a simple pitch. The pitch is that we want to automate or bring AI to travel in a way that the way people book, or the insights that they can derive while they're booking, we improve them based on every customer's preference. So basically, I have a separate preference. Uzair might have a different. Other folks on the team might have different preferences on how they book. So we want to be able to identify customer preference on the way they look at flights, the way they look at hotels, or we connect to their Facebook page, we learn about them, and use that information to give them, or to offer them flights or hotels, or do in a way that is more aligned to them, versus uh, versus um, versus being able to do, or having to do everything one by one. So for example, an automated or intelligent travel agent for you. Right now you have a lot of travel agents who you go to, they ask you all your preferences, and then you ask them to make a trip for you. Folks who travel more, Emma, you've been living in US. I think you can relate to that, Uzair. You can, that there's so much traveling around in these areas and the countries alongside us, is that every time we want to travel, there's a lot of time spent, and we usually don't go to travel agents. We mostly spend time on Expedia or Airbnb or things like that to come up with, or Kayak, to come up with what we want to travel on. So what I'm looking for particularly, I don't have a slide for that right now, but I can send out a write out. But what I'm looking for is a group of people, one, who are very curious to learn or have a very good propensity towards travel. So they know what's happening in the travel industry right now, and they want to learn further about it. That's curiosity is number one that I'm always looking for. Number two is that I want folks who are more full stack engineers who can understand that, okay, how do microservices work? How can you connect data from the back end? How can you scrape data? For example, one thing that I'm looking for is people who can scrape TripAdvisor. Now, you can Google and you can find 20 different scraping examples of 20 different people. However, how can you do it consistently? How can you run something in production in a way that that you can learn about them? Yes, there are APIs available, but the APIs have their own challenges and issues. So so number one requirement is that you should be very, very good, or you should have an understanding about what a full stack engineer does, what are the things, or what is the skill set needed. That's one. Number two is, you should have some proficiency over Python. Python is extremely important for us. We work, everything we do is in Python or sometimes in R. R is more for analytical purposes. So Python is very important. Number three is that I'm looking for people who would be interested in learning about natural language processing. So we have huge amounts of unstructured data. How do you use unstructured data to use towards recommendation? For example, if I'm interested, if I have a family, let's say my requirements are, I'm a family, I want to stay in a hotel which is like 3 star, but it is good for value, and they have, it's more central, and it's close to the public transport area, versus someone who wants to go in a hotel which is a 5 star. They don't care whether it's far or close to the center of the city, but they want extremely good service. They want a car transport. So these are two very, very different requirements. So how can we give a certain set of preferences, and how can we derive a customer or a hotel recommendation or a flight recommendation or things to do, activities, while we generate those preferences for different folks, right? So this is the idea, is to use NLP. Again, there is basic work done outside. There's basic context done outside, but however, there's still a great deal of work that can be done. So let's say if you're interested, right? Uh, let's say you are interested to go forward, and you want to work with us. All I would suggest you is that go download a TripAdvisor book. I mean, there are a lot of them free available. If you go to download one TripAdvisor book, read it into your system, and if I give you certain keywords, can you generate related text to it? For example, if I say hotels in Bangkok, and it's a Bangkok TripAdvisor book, it can tell me that these are the hotels that you are looking for in Bangkok. Or if I say activities in Bangkok, and it says that, okay, these are the activities you can do in Bangkok. So I'm looking for folks who are interested to go and approach that kind of problem. Any questions for me?
Makes sense. This is good. So you're looking for somebody that would help you solve this problem?
Yeah, I'm looking for someone who's interested to solve the problem. I have certain hypotheses of how to approach this, but I'm basically looking for like at least a set of skill set, so that when I go and talk to the person should understand what I'm talking about in terms of natural language processing or Python coding or making a few functions or embedding it to a MongoDB backend.
I was speaking with various campuses and with their career officers, and we need to share this idea with a group of students, either final year or maybe after, or who are in the incubation centers. So that may be interested. I mean, I could help spread the message there. That may be helpful.
Yeah, that'd be nice.
I think what I would suggest, Hamza, is maybe you can write a small write-up on this, and kind of your contact information as well, and then kind of the logistics around it, and then it would be helpful for us to move this around among the campuses, and then also among the participants of this session as well.
Yeah. No, I would be happy to do that.
Yeah.
Uh, one thing, guys. Riz Hashmi sent me a question. I'm sorry I was not able to answer in time. You asked a question: is there any relationship with pricing versus what stores would like to place in shelf? Yes, there is a lot of work that we are doing. We call it space optimization or planogram layout. And there's an entire team. I lead that team. I lead about six different teams. One of the teams, we have three people on it, all three PhDs. They're literally working on what item to place in what position and how can we learn from the past. So we have layouts all the way up to 5 years that where items was placed. Some items have gone out of stock, the supply does not sell them, but we use attribute based information on that, that what this item really did, what did it sell. And based on that, what we did is that we're trying to build out knowledge that what did the item, how did the item perform in different places, and what is the worth of every shelf. So that's something that we are still working on. You guys might feel that we are really behind in on the edge on the cycle of doing data science, but this is the problem when you work in a very large organization. We're the biggest, I think we're the biggest employer in the world, and what that does is that it slows us down in doing a lot of work that we would love to do. However, like we are moving the needle, and we are going forward and trying to build more understanding about how else we can use data science to learn further and improve ourselves.
Okay, so one more question I think that came in from Mr. Abdul Wahab, and I think that's a good question, and it is asked a lot of times when anybody is talking about data science or machine learning. So I think the question is, can you tell us how we can start learning data science or go in this field, or we? And then there was another similar question as well along the same line, but I think what if I had to rephrase it, what the generally the question is that artificial intelligence, data science, machine learning, they all sound like to be very advanced field. But if somebody is like, let's say, starting his college or is in undergrad doing bachelor's, how can he get into this field at that time, or does he has to wait to complete his or finish his degree and then get into this field?
So I have pasted one link, which is the Udemy. I know this is very basic, but Udemy is literally one of the things that I would ask anybody to use this link. Go to this website, learn from this. Just take this course. It's a very cheap course. It's not expensive at all. You guys.
I think you just sent it to me only.
Oh, sorry. To all panelists, to all panelists and attendees. Uh, you guys have all seen it. I don't think anybody has not seen it. You probably all know about this course, but I can't talk more about this course. This is a very good course to work on. There is one more thing that I want to share. Um, um, so my favorite website that I have learned everything from, to be honest, I got hired through this website. This is that good of a website, I would say. Sorry.
Sorry. No, please go on.
Yeah. So kaggle.com is what you all like. Go to kaggle.com, pick up a project, and just keep working on it.
So is there like as far as the time constraint is concerned, can they start right from the day one once they start?
Yeah.
Okay.
You can start today. You can start this evening. You can start tomorrow morning. You can start
Okay.
anytime you need. These are the course. The course that they're doing is that it's a very self-space, and they literally don't expect you to know. Like, they basically expect you to be able to understand what they're saying. I think other than that, there's literally nothing else that they need to learn. Like, there's no prerequisite, if that's the question.
Yeah, right. Okay, that's good to know. I hope, Abdul Wahab, I hope that this answers your question. By the way, everybody is unmuted right now, so we are inching towards the very last few minutes of the session. So if anybody has any question, you can directly ask that question as well.
Okay.
I see
All right.
Tahir.
I
Tahir.
do have a question here.
Yeah,
Yeah.
sure.
Go
It's
ahead.
about your the startup idea you were discussing a moment ago. It would seem that you have a massive cold start problem there because when you begin, you really can't see deals that have closed, right? Or can you? So how do you profile customers when you can't really have a history accessible to yourself?
So you basically what you do is that you pick up the most successful cold start algorithm or the most successful cold start spot. See, this is a problem that we have solved a long time ago in Walmart. Cold
Okay.
start cold start is you show them the top three sellers, and you start
Yeah.
with you
Yeah.
show
Okay.
you
Yeah.
literally
That's
you literally show them the top three sellers, and you say, okay, yeah, you know what would so let's say if I want to show you hotels, I'll show you three hotels, one with extremely expensive, or both all three will have the highest value in terms of their stars, but one would be which of the 5 star with highest value, one would be a medium, and one would be a low end, and we'll take it from there,
okay. Okay. Thank you.
right? And this is something that you learn from A/B testing.
Yeah. Yeah. eh, Definitely.
And we
Hmm.
have implemented so many versions of cold start. I mean, we've been doing cold start since the very beginning of time. Like for 5 years or 4 years, I've been in Walmart. We have done cold start for every single thing. Like this question comes up. Oh, we are launching a new website. What is the cold start? We are making changes in stores. What is the cold start? So that is not a big concern for us.
All right. Thank you.
Yeah.
Hamza, can you please share maybe like a screen with your email address, or like if somebody from this session wants to reach out to you, what's the best way for that?
Yeah. I just sent it a I just sent a message. Okay, Muhammad Bilal Khan asked a question. Some people suggest that data science is just a hype. Bilal Khan, tell them that they are stupid. They don't know what they're talking about. And then we should be focused. And then, okay, so here's the thing. Do you think that people who do PhD are wrong? Do you think people who do masters are wrong? The challenge is that when you're working as an undergrad, you need to develop yourself, your basic, you learn basics, like you learn how to code, you learn how to develop things, and then from there where you go is that you get smarter, you start focusing on things that are going to make uh, make a huge impact. So for example, the entire Tesla, the company Tesla, or the self-driving concept is based out of data science. It is not just a full stack engineer. It uses all of those things, but after that it also uses the concept of research on data science to build things based on deep learning and computer vision. Question from Muhammad Anas is that cold start techniques will introduce a bias. Yes, it will introduce a bias, but this is why you do A/B testing to understand. Like you do multi-blind test, and you start seeing which one works out, which one doesn't work out. You really don't lead with one thing. You use multiple versions of, or A/B testing, and you learn from it that which one actually came up to be correct.
So I'm looking at the questions that were sent in earlier before the session started, and so if you see on the number 5, somebody has sent in a message: which library is best for statistics and data science if we are doing projects with NetFX?
I don't know what NetFX is.
Okay, so okay,
Let me look up what NetFX.
yeah. So if
What is net into? NetFX is a Microsoft .NET framework. I don't know. I've not worked. I don't work on Microsoft. I don't. I really don't work on in that area. But I'll tell you this. See, .NET is just a framework. .NET is your basis of your framework. You can actually run Python on your Visual Studio now. So think about it like that. Or you can run everything in C. So all the base algorithms are written, I think, in C or C++ because everything is converted into a low level language like C or C++. If that's the way. I mean, most low level language is assembly, right? So, but if you go from between Python and C, is that whenever most of the algorithms that you look at right now are all in C or C++. That's the basic level of coding, and then Python is just a package over it. So I would suggest you to start with, look at Python and start doing with that. I don't know if that answers your question, but I hope that does.
Okay, so does anybody else has any questions that Hamza can answer right now? We still have, I think, a couple of minutes before we end the session. I think it was a very, very interactive and very engaging session, and I thank you all for joining in. If anybody has any last minute questions, please feel free to send us our way.
Yeah, I think one thing was there. I don't know if you mentioned, but we wanted to talk about the FAANA website.
Yeah. So, do you have that website open?
Yes.
If you can share, I can talk about it a little bit.
Go ahead.
So yeah, just a little bit about the FAANA under which this session was being held. So we are FAST Alumni Association of North America, and I have mentioned it in the beginning as well that our main mission is to engage alumni and provide a platform to counsel and support current graduate students and to help them in any way we can. And this webinar series is part of that same approach where we are trying to engage the current students and to guide them what future fields that they can opt for. And also under FAANA for last several years, we have been supporting deserving students via financial aid program. And going forward, we are also planning to invest more in the areas of research and development. And I think what Hamza has mentioned can shape out to be a good initiative on that front. Which would in turn, develop and promote innovation across all FAST campuses. So right now, we launched this series, which we are calling it webinar series. The first session was about the entrepreneurship and an entrepreneur's journey, given by Mr. Fahad Aziz. And then the second one was given on the artificial intelligence, given by Noman Sheikh, and this is now currently the third session, which is by Hamza Farooq. And if you can, and also we have, so we are pretty much present on all the on all online channels. We are on Facebook, we are on LinkedIn, we are on WhatsApp as well. And then you can reach out to us via board@faana.org. This is our website, faana.org. You can find all the information over here to reach out to us. So feel free to get in touch, and we would be more than happy to kind of work out with you. And if you have any questions or if you need any support, we'll be more than happy to extend a helping hand. With that being said, Hamza, do you have any more things to share, or is that it?
I think what I would say, what I would say is that if anybody, I'll send a write out, and we'll take it from there. But I would really like to get people who are seriously interested in that and not in like, oh, we're gonna, it's a quick, easy win. This is going to be a tough. That internship that I want to offer is going to be tough, but it's going to be rewarding at the same time. We intend to open up if things work out, we intend to open up an office in Pakistan instead of going to the easier way of going to India. I have a co-founder who works in India, who's from India, so there's always going to be. It's always for them. It's always easier to go to Bangalore and set things up. I want to say that if this venture is successful for us, we'll go ahead, hire people, set up shop in Pakistan, and directly start from there. So There's a lot of opportunity, but I'm really looking for people who can do multitask and who are more curious rather than closed up in their mind that this is the only way things will work. What you see is, and what you learn is when you start implementing data science, there are a lot of things that you have to let go, that you hold that you think are solid truths. You actually have to let go of a lot of things and come to the reality that this is this is not the way the world will work and converge in a way that it's supposed to, rather than what your data or what your experiments or what your statistics. So that being said, love to hear back from some people at least to say, okay, this is what we think about the problem and this is how we want to go ahead and help you solve it. So
And
I'm open to.
just to reiterate Hamza's email address, he has sent out in the chat box as well. It's hamza50 at gmail.com. And, hopefully we'll shortly be sending out a short write-up as well, which will have more information of, what his plans are and how you can get in touch with him. So if you have any questions, just feel free to reach out to him directly as well. Hamza50 at gmail.com.
All right. Perfect.
Okay.
Thank you very much.
Thank you, everyone.
All right. Thank you very much for everyone for joining us. And it's been a great pleasure. And hopefully we'll be back soon with our fourth series. And till then, take care and Allah Hafiz.
Thank you.
Yeah, it's much appreciated. Thank you.